2 sets of optimally designed cams, controlling valves in a completely new way. In an innovative new approach, Honda has implemented high-output cams and fuel economy cams, intelligently adjusting valve timing and lift to provide both superior performance and excellent fuel economy. The superior driving performance that Honda is known for. World-leading environmental performance in a light and compact engine. The new 1.8-liter I-VTEC. Honda set out to achieve significantly higher levels of both driving performance and fuel economy. The key focus was on reducing pumping losses to achieve a significant improvement in fuel economy. In conventional gasoline engines, the gas pedal is directly connected to a throttle valve that opens and closes, adjusting the volume of intake air. Under low load conditions, when the driver is pressing lightly on the gas pedal, the throttle valve is opened just slightly. This narrowing of the intake passage causes resistance, pumping losses, and has a negative impact on fuel economy. The reduction of pumping losses is a major factor in improving fuel economy. During acceleration and other high load conditions, the high output cams help deliver superior driving performance. During cruising and other stable low load driving conditions, the fuel economy cams retard the closure of the intake valve. Then open the throttle valve wide. With the throttle wide open, the engine output would normally be very high. Yet since the intake valve closure is delayed, some of the air-fuel mixture is momentarily expelled back out of the combustion chamber, minimizing unnecessary output and thus improving fuel economy. Thanks to this synchronized operation of the intake and throttle valves, output is optimized and pumping losses are minimized. Meanwhile, the drive-by-wire throttle mechanism functions in concert with the switch between high-output cams and fuel economy cams to provide highly precise throttle control for smooth driving with minimal torque variation. In pursuit of even higher fuel economy, the new 1.8 I-VTEC engine also incorporates the latest friction-reducing technologies. The piston skirts are shot with the solid lubricant molybdenum disulfide, while an ion plating process is used on the oil rings to ensure reduced friction. Plateau honing of the cylinders results in a smoother surface and improved oil film retention. The result is a 10% reduction in friction. Through this combination of new VTEC technology and comprehensive friction reduction measures, the new engine realizes a major improvement in fuel economy and an increase in output. During cruising, it delivers fuel economy on par with that of a 1.5-liter engine. Performance is improved at all engine speeds to ensure lively response, with special attention given to increasing low to mid-speed torque. For the intake system, variable length intake manifolds are implemented. Controlling the effective length of the intake manifold, making it longer at low RPMs and shorter at high RPMs, ensures that the optimum intake ram effect is maintained to deliver torquey driving performance throughout the RPM range. Another innovation introduced with this new engine is piston oil jets, previously only featured in high-performance engines. Superior cooling ensures improved durability against knocking, allowing the engine to run on regular gasoline with a high compression ratio of 10.5 to 1. These innovations contribute to achieving class-leading performance, high output of 140 horsepower or 103 kilowatts, and high torque of 17.7 kilogram meters or 174 newton meters. Especially in off-the-line acceleration, the new engine delivers performance on par with that of a 2-liter engine. Along with improved fuel economy, the new engine offers cleaner emissions performance. The new I-VTEC engine employs an airflow meter and a linear airflow sensor, along with the latest control technology, achieving extremely precise control over the air-fuel ratio. Constantly maintaining the optimum air-fuel ratio contributes significantly to increased combustion efficiency and cleaner exhaust emissions. Also, a newly developed integrated cylinder head and exhaust manifold are employed, with 2 catalytic converters positioned immediately after the manifold. Further, the introduction of high-temperature combustion gases into the catalytic converter raises its temperature rapidly, helping to optimize scrubbing performance soon after the engine is started. These innovations help the new engine achieve world-class clean emissions performance. To further improve the I-VTEC engine's fuel economy and make it suitable for a broader range of vehicles, size and weight reduction have been achieved. The all-aluminum lower block contributes to the lightness and quietness of the engine, and lightweight plastic materials are used in the head cover and other components. Aluminum rocker arms and high-strength cracked connecting rods provide significant reduction in the inertial mass of moving parts. Size reduction has been optimized in every detail. For example, the cam chain is narrower than that used in conventional engines. The result is an engine that is both lighter and shorter overall than a conventional 1.7-liter engine. The 1.8-liter I-VTEC, which varies the actual air intake volume according to driving conditions, is a leading-edge intelligent engine that contains the finest of Honda's VTEC technology and control systems expertise. Introducing new advances in VTEC technology, Honda is leading the way, delivering the fun of the drive and environmental performance.